All right, very first thing you want to do is just like we were doing yesterday. You want to factor everything as much as possible. And that was pretty much the same thing we did yesterday. So whether we're adding and subtracting or solving, you still want to factor everything as much as possible. Okay. Second thing you're going to do is you're going to state the next two steps, steps 2 and 3, kind of go together because you're going to state the excluded values. And one thing they may do on this one is that I noticed that for this section, sometimes they change the word on this one. Sometimes they don't say excluded values. Sometimes they'll say restrictions. But it's still the same thing. Whether it's excluded values or restrictions, it's still the same thing. This is still your least common denominator equal to 0. All right, now here to me is where the big change happens, and it's a little bit easier. Yesterday we had to rewrite all the questions and find common denominators, and you had to change the bottom numbers and change the top numbers and do all this stuff and do everything there. And if you're just adding and subtracting, you have to do that. With solving, here's where it gets easier: is we're going to multiply every term. We're going to say we're going to multiply all terms by the LCD. Okay, so we don't have to rewrite anything. We're just going to multiply. And what happens when we do the multiplying is we're going to cancel a bunch of stuff out. So it's actually really easy multiplication when it comes off of it. And then that's going to leave you with a big long problem that's left over, and you're just going to solve the remaining problem. All right, now, and then the one little thing we'll say with this one is that when you're solving this, you might have to factor to solve. Maybe, maybe not. But it may not, when you get to the end, it may not just be like x plus 2 equals 3. When you get to the end, it might be that it's x squared minus 5x plus 6 equals 0 or something like that. So you might actually have to go back through and check and go through that one. And then the one little thing you have to do, and this is where you're going to have to check some stuff. But this is like super easy checking. This is like the easiest checking you've ever had to do for a math class. All right. You must check your answer or your answers, depending on how this thing is set up. Now, but the check on this one is that you just look to see that it's not in your excluded value. So you must check your answers to make sure that they are not on the excluded list. Okay, so this one, you're not having to go back and check it like you did like way back when you'd have to take the number and plug it back in the equation and solve it and work it out and do all this stuff. No, no, no. This one is very much just here. I've got my answers and I'll look and see if it's on the list. So basically there's a list of answers that says, all right, if these answers show up, you kick them out. They don't work. I mean, that's really what it comes down to. Okay, so there's basically about 3, maybe 4 different types of questions that you might run into. We'll show you all those different types and just kind of so that you're not, freaking out when you see the possibilities that show up here. So let's just kind of run through and show you all the different possible questions that you might get when you go through these. All right, so for number 1, let's start you off with just and this is almost like I almost say it's like almost too easy of a fraction, but it's almost like too easy of a fraction for one like this. You may get something like this where you've got 7 over x plus 1 equals x plus 5 over x plus 1. Okay, now for one like this, and this one's a little bit sneaky, because this is one that um, you can do this one a couple of different ways when you're going through the problems on these. But here's where they kind of get sneaky, and this is a tricky one that you do this. If you do it like the way it's supposed to be done, well, we'll go ahead and do it this way. Your least common, you only have one denominator, correct? There's nothing you can factor this one, so your least common denominator is x plus 1. So when you talk about excluded values, you have to exclude whatever this is, if your least common denominator equal to 0. So the only value I have to exclude is x equals negative 1. Okay, so there's basically step 1 and step 2, because there was no factoring on this one because everything is factored out. We've got our least common denominator that's here, which tells us what our excluded value is. So then what we're going to do is we're going to multiply both sides by x plus 1. Okay, and here's the good thing about doing that. This will cancel this, and this cancels that. So 7 is equal to x plus 5. Just subtract 5 from both sides, which means that x is equal to 2. Okay, now, and the one little thing you have to do at the end is, this is how easy it is to check. The answer we've got is 2. The excluded value was negative 1, so it's not, this number is not up here, so does it check? Yep, it's good to go. And that's how easy the check is that you look at this answer that's here, and you'll have an excluded value or excluded values, and as long as it's one of those, if that number had shown up here on the list, you would X this one out, and then you'd go on to the next one. Okay. Now, here's kind of the shortcut, and here's what I'm saying, the little bit of tricky on this one. If it's the same thing over itself on both sides, you can just cover up the fractions and just solve what was on top, which is what we did here. Now, if those two were different, if this had been like x plus 1 and that was x minus 1, then we'd have a little bit longer problem. But in that case, that one, it's almost like a trick. I wouldn't say it's a trick question, but it's almost like we're trying to be a little bit sneaky with you there. Okay, so there's one question, and again, still same steps, kind of figuring this thing out. All right, so for example 2. Let's do this. Let's go with x over x minus 3 minus x over x plus 3. That equal 2 over x squared minus 9. All right, so this problem, there is just a little bit of factoring that you can do. That this is good, this is good. The only factoring you've got is on the x squared minus 9. So for that one, hopefully you realize that's the difference of two perfect squares. So if that's x times x, 9 is 3 times 3, so that's going to make one of them x plus 3, the other one would be x minus 3. All right, and for least common denominator, basically just tell me everything that shows up in the denominator. There's an x minus 3, and there's an x plus 3. So that would be your least common denominator of x minus 3 and x plus 3. Okay, and whatever that least common denominator is, that's what you have to exclude. So we're going to exclude x minus 3 equals 0 and x plus 3 equals 0. And solving that one, that's 3. Solving that one would be negative 3. Okay, now to me, this is the longest part that you have to do, because if we've got this thing rewritten where it's all factored out, where we factored as much as we can, we've got to go back and take every single thing in here and multiply by x minus 3 and x plus 3. And this is, to me, the part that kind of takes the longest, because you've got to go back and rewrite this problem, basically. Equals 2 over x plus 3 x minus 3 times x plus 3 x minus 3. Okay, I'm going to slide this up a little bit. Okay, so that becomes our new problem. And again, to me, the long part about that one is that you've got to rewrite the entire equation. And some people might be going, well, okay, well, this is longer than what we're doing yesterday. Okay, it was, but here's where we're going to make the work go a whole lot easier. Because once you multiply through by the least common denominator, all the fractions are gone. This x minus 3 cancels out that x minus 3. That one cancels that one. That will cancel that, and that will cancel that. And that's what you want, and that's the whole purpose of multiplying by the least common denominator. Every fraction's gone, and you've got just whole numbers left over. And then just write down what you have left over. You've got x plus 3 times x minus x times x minus 3 equals 2. Okay, so and again, all the fractions are gone, which is what we want, because most people don't like fractions. So now we've got a step in the right direction. Now you just got to work this thing out. You've got some distributive property here that you've got x times x plus 3. Well, that's x squared plus 3x. This one you've got, and here's where you have to be a little careful. It's negative x times x, and then negative x times negative 3. So that's a negative x squared plus 3x equals 2. All right, and it's been just a little bit since we did some big solving equations. I think it's been a couple weeks since we've done that. But don't worry about the right-hand side for a minute. Just worry about everything here. Best thing to do is rearrange it so all the like terms are together. So you've got the x squared here. You've got the minus x squared here. You've got the plus 3x, and then the plus 3x. And then you can combine like terms. Well, x squared minus x squared will go to 0, so that one's out. 3x plus 3x is 6x equal to 2. And remember, a lot of times people jump out and go, the answer is 3. But remember, in this case, you've got to divide both sides by 6. So x would equal 2 over 6, which when you simplify that, would be 1/3. All right, now, again, here's where you have to check it. And basically just kind of ask yourself a question. All right, does it check? Well, if the answer was 3 or negative 3, you got to kick those answers out. That one's 1/3. So it checks and it's good. Okay, let me give you one more kind of like that, and then we'll show you the other type version problems that's here, and then we'll wrap this thing up for today. Okay, so staying in that same kind of pattern with the problems where they look kind of similar. We'll do one more example here. And again, then we'll change kind of gears the way it looks on these. All right, let's go with x minus 1 over x squared plus 3x plus 2. And I've got x minus 1 over x plus 1. Okay, so first, now again, if it was here, we wouldn't have to do any factoring. If it was just this part, we'd have our common denominators. We could figure it out and go from there. But because the x squared plus 3x plus 2, we've got to take this part we have and we're going to factor it and rewrite it. Okay, now here's what we're going to do. To save a little bit of time when we do these, we're going to spread these out as much as we can. That we're going to make this x minus 1 here. And the factoring should be really easy. It's not going to be super complicated. This one, the only factors of 2 are 1 and 2. All right. And again, leave a little bit of room here because we're going to spread these things out a little bit. Then we've got 2x over x plus 2 equals x minus 1 over x plus 1. All right, and that's going to help us. And again, what we're going to do is we're going to save a little bit of work on this one. So whatever your problem is, if you have it, just space it out when you factor it out. And that should save us some work because what we're going to do is we're going to figure out that the least common denominator is just x plus 1 and x plus 2. Okay, and we have to exclude x plus 1 equal to 0 and x plus 2 equal to 0. Again, that one will just subtract 1 from both sides, and this one will subtract 2 from both sides. So we're just excluding negative 1 and negative 2. Okay, so if you're having one of these homework problems that you're working through, my suggestion is that you go ahead and factor it, and when you factor out what you can, spread these problems out because now we're going to go back and take everything up here and multiply it by the least common denominator of x plus 1 and x plus 2. We'll do the same thing here. And that way, that'll speed this thing up a lot because then we don't have to go back and rewrite this thing one more time. So we'll do 2 steps in one, basically. Okay, so that x plus 1 cancels that x plus 1. That x plus 2 cancel that x plus 2. That will cancel that, and that will cancel that. Okay, and the hardest thing to do is make sure you don't leave anything out. For this one, we've got the x minus 1. This one has a 2x times x plus 1. And on the right side, we've got an x minus 1 and an x plus 2. All right, and then we'll just start working it out. There's nothing you can do with the x minus 1, so it's good like it is. For this one, a little bit of distributive property. So we've got 2x times x, which would be 2x squared. 2x times 1 would be 2x. For the right-hand side, you are going to have to do the full method. So x times x for x squared. X times 2 for 2x. Okay, negative 1x and a negative 2. Okay, and again, here's my suggestion on these. I would say on the left-hand side, and don't worry about the right-hand side for a minute. We'll come back to that one, so just kind of block that out for a minute. Just block it out. Just forget about it for a minute. Take this left-hand side and rewrite it so it's in descending order, so we can get all the terms together. We've got 2x squared plus 2x. That technically would be a 1x minus 1. So if we combine all the like terms, that's 2x squared plus 3x minus 1. Okay, and remember with equations, you can pretty much do one side at a time when you're simplifying on these. So do everything you can do on the left-hand side. And the good thing is if you stay on one side, you don't have to worry about changing any signs. You just rearrange it and combine like terms once you've done the distributive property. Then we'll do the same thing on the right-hand side, which actually will be a lot easier because it's already in descending order. We just got to add 2, or in this case, subtract 2 minus 1 to make that 1x. Okay, and to solve this equation, we've got to start moving stuff all to one side. We've got to get all the x's on one side. So for this one, we're going to take away the x squared and then go over here with it. And that would leave you with just 1x squared. And now, the catch is, if you start with x squared, now we've got to get everything to this side. So we're also going to move this 1x from over here. And we're going to move this minus 2. And we're going to move it over here to the left-hand side also. Okay, so that gives us x squared plus 2x plus 1 equals 0. And another 0 and another 0, so it's just that equals 0. And if the x squared term had gone away, then we'd put the x's on one side and numbers on the other. But because the x squared term didn't go away, we've got to pull it all to one side, and then we have to factor this thing out. But again, the factoring should be easy because what's the only factors of 1? 1 and 1. So that's like easy factoring. That's x plus 1 and x plus 1 equals 0. So when you solve that one, doesn't matter which one you pick, just let x plus 1 equal 0. So then x equals negative 1. Okay, so we got an answer, but we got to check it. This one says you cannot use negative 1. So even though we've got an answer here, we've got to chunk it. So if the only answer we had doesn't work, then you have no solution. And again, the reason why that is, if we took this negative 1 and plugged it back in here to this part of the problem, you would get negative 2 over 0. And you can't have this thing equal to, you can't say, all right, this thing's got to equal an undefined number. Because if it's undefined, it means it's not possible. And if this number is not possible, then there's no way you can get a solution using that number. So, occasionally, sometimes the answer you get just doesn't make any sense. So then you just have to chunk out that answer. Okay, so that's all the problems kind of in that category where you've got a lot of the x plus y's and x plus 1s and y plus 1s and those kind of routes with it. The second kind of problems that you have will look something kind of like this, that they're going to look a little different. And we'll go through a couple examples on this one just so you can kind of see what's happening here. All right, so for example 4, you may get one like this, where you got 1 over y plus 1 over 6 equals 8 over 6y. Okay, good part is there's no factoring involved because there's just one number and one letter, right? So for that one, your least common denominator, well, all you have are y's and 6's, so your least common denominator would just be 6y. Because that's all that's there. It's just a y and a 6. So when you go to exclude, that's 6y equal to 0. Well, that's just y equals 0. Because if you divide by 6, that doesn't do anything but the 0 divided by 6, still just 0. Okay, now this one, we'll go ahead and rewrite it because it's not very long. So we're going to do 6y times 1 over y plus 1 over 6 times 6y equals 8 over 6y times 6y. Okay, so on this part, these two y's cancel. Those two 6's will cancel, and over here, the 6's cancel, and the y's cancel. So for this one, we've got 6 times 1, which is 6. We've got 1 times y, which is just y. And then we have 8. And that's a really, really, really easy equation to solve because you've got 6 plus y is equal to 8. We'll just subtract 6 from both sides, and y equals 2. Okay. And again, if you check it, the only excluded value was 0. That answer is not 0, so that one's good. Okay, and then the last problem that you will see, we're going to kind of borrow this from, anybody remember the show Girl Meets World?
Yeah.
Okay, we're gonna steal a question from that show. So here's what we're gonna do. We're gonna make a word problem out of this. If you remember in the you may or may not remember this episode. Riley was the main character, and then Maya was her friend. I think it's right. They got into an argument about something, and then they had a problem in class, and the dad was like, okay, if you have Maya and Riley, and they've got to, I think they had to wash a car or they had to wash something, had to paint a fence. And he's like, if it takes one of them 2 hours to do it and the other one 3 hours to do it, how long is it going to take them if they do it together? And Farkle jumps up and goes, oh, I know what the answer is. And he's like, Farkle, be quiet. I don't care. Because that was always what happened to Farkle. Nobody wanted to listen to Farkle. That's what I was thinking. It was washing the car. The whole point of the story was that he got back that they were mad about something. He was just trying to get them to work together. That if they started working together and talking, they would forget about what they were angry about, and they'd be friends, and everything would be great, and go from that. So, this is one of those problems. It kind of popped up a little while back when we were doing this. I was like, hey, I remember this from Girl Meets World. This is a problem that they were doing, and Farkle, we'll actually let Farkle, say what the answer would have been for this one. So here we go. We're going to do one little small word problem on this one. All right. We want some volunteers. Anybody want to volunteer for this? You don't have to do anything other than just volunteer your name. Anybody good for it? Rayline says, all right, Rayline's in. So there we go. All right, we're going to give like the super biggest, hardest online test you've ever had to take. It's going to take you 5 hours. So Rayline can take an online test in 5 hours. All right, I'm going to pick on Savon because I've had him before. He'll be all right. Savon can take the same test. And we'll say 6 hours. All right, and the question we're going to ask is how long will it take if they work together? Okay, and every word problem that you would ever do like this one, it basically sets up on the same way. Now, here's the first thing I don't want you to think, because sometimes people go, oh, well, if they can do it in 5 and they do it in 6, it's going to take them 11 hours. And I'm like, now, wait a minute, think about it. They can do it by themselves in 5 and 6 hours. So if one of them starts helping, shouldn't it take less time? And people go, oh yeah, that's right. Yeah. So if one person can do it in 5 hours, somebody else can do it in 6 hours, it's not going to take them 11 hours to do it, because after 5 hours, Rayline's done, and then we don't have to do anything else. So it's got to take less than 5 hours, because they're going to help each other out. So they're going to cut the work in half. Here's all you have to do. You're going to take whatever two numbers you have. We know they're going to work together, so we're going to add together. You can take whatever those two numbers are and put that as over 5 and over 6. They're going to finish the one test, or the one car they're going to wash, or the one fence they're going to paint, whatever the problem asks you to do. And basically, you just put a variable, X or Y or P, or just pick a variable and put that over the top, and then there you go from here. Okay, so it's just X over one number and X over the other number, and that's going to equal the one test, or the one whatever they're going to do. And basically, it's just a rate that if we were talking about in 1 hour, he would do 1/5 of the test in 1 hour. He would do 1/6 of the test in an hour. So then we can figure out like an hourly rate of how this thing's going to work, and then we can figure out how long it's going to take them. And your least common denominator is really easy. You just multiply those two numbers together. Okay, and then we'll do the exact same thing. We're going to do 30 times the first number. We're going to do 30 times the second number, and we're going to do 30 times that last number. All right, and again, everything will cancel, because 5 will go into 30 6 times. So that leaves this with 6x. 6 will go into 30 5 times. So that'll make that 5x, and then 1 times 30 is 30. Okay, 6x plus 5x is 11x, equal to 30. So then to get the answer, and we'll put that back up here, we're going to divide by 11, and I don't know exactly what that is. It's 2 point something. Let's see what that's going to be. 30. If we round it off to one decimal place, that's going to be about 2.7. Okay, so any of those problems that you have like that, where it's like X over a number and then X over that number, you're just going to multiply by the least common denominator. I'm going to see if I can find a good word problem to mix in with that one, just because to me that's an easy word problem once you kind of get it figured out. But that's kind of the setup. So whether it's a word problem or not, if it's just that's your problem, again, just take the 5 and 6, multiply it together to get 30, and then multiply everything by 30, and then work it out from there. So that's one again where Farkle was going, oh, it's 2.7 hours. And then the dad was like, it doesn't matter, Farkle. The point wasn't that. The point was just to get them back together so they'd be friends again. So to me, it was weird that like every year of school, her dad kept moving up with her. That would be brutal to have your dad be your teacher for like 3 years, 4 years in a row.